Welcome back, folks. I'm going to solve a question from page 371, question number 12, and we are on chapter number 8 right now. Okay, the average loan issued, the average loan amount issued by a small short-term lender is 975 with a standard deviation 195. Find the probability that the lender issues more than $1,000 at a random to a random borrower. Now, before I start solving this question, this is question number 12. uh, Before question number 9 there is a line written that assume the population data is normally distributed. So that line is really important, because if that line wasn't written I couldn't solve the part 1. This formula, uh, which we've learned in chapter 7, z equal to x minus mu divided by sigma, we can only apply if the population is if the data is normally distributed. So now in this case we are told that the population data is normally distributed. So mean value for the population is given to me 975, and standard deviation sigma is 195, and we are looking for the probability that more than $1,000 to a random borrower. What is the probability of that? X greater than 1,000. That's what we are looking for. So again, I'm going to first of all draw the normal distribution graph. That's how it's going to look like. And here the mean value is 975, and the standard deviation is given to me, which is 195. All right, so how I'm going to solve this? It's no sample size is given to me, so I don't need to worry about the CLT theorem in this case. I can just straight up use this formula. So Z value, I'm going to first of all try and find out. X value is 1,000. So 1,000 will be on this side because this is 975. So 1,000 is always bigger. And then 1,000 minus 975 divided by standard deviation, which is equal to $195. So let's try and solve this one. 25, I'm gonna do the calculation on my calculator. 25 divided by 195, 195, that's gonna come across as 0.1282, but I have to have the z value up to 2 decimal places, so 0.19. So correspond to the z value of 1.19, I'm going to look into the table. So the table is up here, 0.19, 0.19. That value will come across as 0.5753, 0.5753. So I'm going to write that value here. So probability value 0.5753 for x less than 1,000, because we always find out the probability from 0 goes up to this point. And what I'm looking for, probability x greater than 1,000, I'm looking for this section. So probability of x greater than 1,000 will be equal to 1 minus probability of x less than 1,000, and that will be 1 minus 0.5753. And now I'll do the math. 1 minus 0.5753, that comes out to be 0.4247. So that will be your answer. Or in another way, I can say that uh, the that the determine the probability. So the probability that the lender issues more than $1,000 to a random borrower is 0.4247. That is the probability value. All right, so now let's look into the part B. At most 1,000 on an average to a random sample of 20 borrowers. So n value is given to me. So I will apply the formula of x bar now. So this is a cent limit question. So the formula is going to look like z equal to x bar minus mean divided by sigma upon square root of n. This thing is called standard error. Standard error. Okay. And this is same as mean of the means of the sample. Okay, now let's solve this question. Okay, before I start solving this question, I will redraw the diagram. Whenever we are working with the center limit theorem, the graph should look like this, that x bar values. Okay, x bar, so it is 1000, so x bar value will be on the right hand side because this is 975, so x bar is 1000. And I have to look for whether I am searching for the area before the 1000, well, whether I'm looking for this section or this section. So at most $1,000 for the 20 borrowers. So I will shade this section. This is the section which is under consideration right now. Okay, makes sense? Now what we're gonna do here is I will just write the other values, n equal to 20, and now z equal to x bar, which is 1000 in this case. So minus the value will be 975, and then it will be standard deviation, which is given to me as 195. 195 divided by square root of n square root of 20. Before I start solving this question, I'll again remind you, make sure you read the statement carefully. At most $1,000 on an average to a random sample of 20 borrowers means a 20 borrower sample. If I take their average, it should be 1000 or less, at most $1,000. That's what we are looking for. So to these 20 borrowers, you paid some money. So we, rather than counting the individual money, their mean is 1000 we are talking about. All right, so this will be 25 divided by 195 divided by square root of 20. So first thing I will do is I'll do the math on 195 divided by square root of 20. That's what I will try and do. So whoops, my calculator isn't working. Oops, 1 second, guys. So let me just quickly open my calculator. So 195 divided by square root of 20, 43.603. I can put it here. So 25 divided by 43.603, which comes out to be z value as 0.57. Now correspond to the z value of 0.7. I'll try to look for the values. So z value of 0.7, 0.57, 0.57. This is 0.7157. 71. Oops, let me, yeah, 0.7. Whoopsie, what I am doing, it is this 0.7157. 0.7157. So probability value is 0.7157. So this will be probability of x bar less than 1000 is equal to this much. So that's how you're gonna solve this part B. All right, now part C, between 1000 to 1500 on an average. Now I'm not gonna solve this question, but I'm gonna give you a hint how you're gonna approach this question, and you try and do it. So you try and solve it by yourself. So between the two numbers given to me now this time. So in this scenario, I will again draw the distribution graph. Oops, I don't know why this is not working. Anyhow, let's see what I can do here. Just cannot type in. Oops, again, thank God it started working. So this will look like this. Again, I'm going to draw the graph. and between I'm looking for 1050 on an average random sample of 20 borrowers. So here X bar value is not here. X bar value will be 1000 and mean value is 975 and the other value is 1050. So I am looking for this section, this shaded section. That's what we are looking for. So what we're going to do here is we will find the probability up to this point minus probability up to this point. That's going to give me this whole section. That will be the answer. So what I need to do in this question is probability of between 1050 x less than 1000. That's what, whoops, I should have written it other way around. 1000 and 1050, and that will be equal to probability of 1050 minus probability of 1000. Okay, and these are X bar values because this is for a sample of 20. So for this one, what you're gonna do here is you will find the z-score. Z-score correspond to 1050 minus 975 divided by 195. 195 divided by square root of n, which is 20, minus here 1000. Well, we don't subtract the z-scores. So first of all, you find the z-score here for this one, and then you find the z-score correspond to this value, which you've already figured out in the previous part. So 1000 minus 975 and 195 divided by square root of 20. Don't start subtracting the z-score. You don't subtract the z-score. That will give you a wrong answer. Okay, so what you're gonna do now is you will find the probability correspond to this, which is 1050 for probability of, here I should have written x less than 1050 here, and here I should have written x less than 1000. So this is the probability of x less than 1050 and then minus probability of x less than 1000. That's what you're going to do. So correspond to z-score, first of all find the probabilities, find the probability here, whatever z-score you're going to get here, and those probabilities, subtract those probability, that's going to give you answer. So hopefully you've been able to understand how to solve this question. Now let's look into another question. So I'm going to try and solve this one now. So question number 17 to 24, it's given to us that use the center limit theorem to find the probability to indicate the event, assuming the distribution of the population data is not known. So now we have to use the center limit theorem. It clearly says to us in this question, the city, in a certain city, the employees work on an average of 18.2 hours overtime every month with the standard deviation of 7.8 hours. What is the probability that on an average the number of hours worked overtime each month by a random sample of 130 employees in the city exceeds 20 hours? So we are given the formula again one more time. Before I write the formula, let's write down what is given to me. Average mu x bar, which is equal to 18.2, and standard deviation, this is equal to mean. Standard deviation sigma is given to me 7.8. What is the probability on that the average number of hours worked over time last month by a random sample of 130? N value is 130 and exceeds, x bar is 20. We are looking for probability that x bar gonna exceed 20. That's what we are looking for. So if I draw it on the normal distribution graph, so this, let's say x bar is 20, I'm looking for this section. So that value will be equal to, 1 minus probability x bar less than 20. and that's how we're gonna solve this question. So everything is laid in front of you. Hopefully you will be able to answer this question. So I'm not going to solve this question, but I just want to tell you. So from my side, the homework will be, if you can try and do question on page number 371, you can try and do question 10, 11, 12, 13, and then for page 372, you can try and do question number 17 and 19 and 23 also. And one more thing, I will highly encourage everyone to try and do one question on the finding the sample size also. So sample size, where you have to find the value of n. So let me just see if I can find an example where you have to find the sample size. Is well, okay, I could not find it for the time being. Let me just tell you the example. Give so example 8.1. Example 8.1. One second. It is, yeah, it is example 8.1c on page number 366. So example 8.1c, page number is 366 is 66, where you have to find the n value, means sample size. All the rest of the values are given to you, and you had to find the sample size of a given question. So hopefully you were able to understand this concept of 8.1. I'll see you with another video. Till then, goodbye.